Okie dokie. Hello, everyone. So I'm going to carry on with the Copper Monkey series where I'm just going to build out a payment gateway system just a little bit at a time. So this is going to be a long journey as we build out this project. Dive on chat. Let me know if you're there, whether you have any problems. Let me see if I can get the chat window open. So I'm trying something different. So sorry if you can see me, seeing me, but that's just the way life is. While I try and stream just through my normal rig. So yeah, cool. I'm live at least. So give us a thumbs up and let me know if you can hear me correctly. Right. So as part of the payment gateway, one of the things I've been doing is let's open up a new terminal here. Let's dive into the project, shall we? So let's go to dev GoLang samples, GPL Taylor. I'm going to Copper Monkey. Don't like the way that PowerShell cycles through folders. It's annoying. Let's go into here. So we started off with this. We've got a basic Cobra thing. I'm not going to go into it into great detail because I've done it in the previous videos. But we've got an execution path. We've got a Cobra stuff that's getting set up here. And one of the things I want to do is do a request payment. This is going to do a request payment and then save it to the database. So this is the command structure. This is dead easy stuff. There's no actual real code here yet. But at the moment, there's just this skeleton line, which is just saying, add payment request, which is fine. Can I zoom in just a little bit, just to make it easier for you? There we go. And therefore, what I need to do is actually fill out this code a little bit more. I now need another module, another package, which is going to handle the database for me. So what I want to do eventually is I want to host all of this on AWS. So what I've done is I've had a bit of a play about it, and I think that really DynamoDB is your puppy, isn't it? That's the boy. That's the thing that a lot of people are using when we're looking at AWS and we're looking at creating, these NoSQL type databases, which I think are really good for databases at the edge. So close to the customers, they're quick, they're fast, they're easy to manipulate, they're easy to change. There's no major schema, although of course there is a schema with DynamoDB and others. But it's a flexible system that allows you to add and change it. More flexible than SQL Server with fixed tables and columns and views and stored procedures to CRUD them. That, if you're ever in that world, that can get a little bit painful. When you're at the development level where you're not quite sure what it is that you're making yet. So I've gone through this already, and what I've done is I've created a README file that's just condensed it a little bit. So if we have a look at this, hopefully what I should be able to do is change this all so that you can see my full screen. So hopefully you can see a little bit more of the code now. Once again, shout out in chat if there's anything not quite right. Don't know where the chat doc's gone. Oh, was it there already? Just didn't see it yet. It's there already. So shout out in chat. Keep an eye on it. If there's any problems, let me know. Right, so I've condensed this down. I know that this is live coding, but no one wants to watch me just look at the screen for 45 minutes going, I don't get this. So I've condensed it down a little bit after doing some tutorials. I've done probably 10 MongoDBs, I've done lots of Cosmos DBs, but I've only done a handful of DynamoDBs, and that was actually quite a while ago. And things have moved on. So what I'm going to do is I'm going to run this in Docker. So I've got Docker machine set up. This is then able to run this DynamoDB in Docker. So you can do all your local development and you can do all your local testing. This is got a remove flag on it. So once this is closed and finished, that database is gone. So that's fine. What I want to do now is set up some aliases on the command line. This is pretty cool stuff. What we can do is we can alias the SQL command to run these commands. And then we can alias the AWS command to run this, which I think is pretty awesome. Then what we can do is we can run the AWS command, which is actually running this command here. And we can kind of just hit this out, right? So we can, let's go all the way to the edge. What we're going to do is let's yank that into the clipboard. We're going to create this table called pending client payments, and I'm just playing at the moment. I've not got the structure right, not got the schema right, not got the names right, I've not got the attributes right. I'm just messing. So we're creating this basic schema. Bank account is going to be the primary key, for want of a better word. And then we're going to insert just a test account in there. So let's have a quick look. Let's see if that works. In fact, let's have a look. AWS. Just making sure that I'm in the right console. Awesome. So that looked like it worked, and that looked like it echoed back the details. So we can see, creation time, you can see details about the actual database table number that's actually been generated. There should even be an ID, but let me have a look. Oh, it's bank account, of course, sorry. So now that's done, let's see if I can run a select statement on that. Now that we've got some data in there. So let's yank that. Let's dive down into here. Let's run a select statement, and we should come back with an item. No, we didn't. So I'm confused actually. I should have come back with a couple of items there. Let's have a look again. Let's run this. Yank that, go here, clear this out. Let's yank that in. Okay. Let's run the query again. And there's a couple of good UIs that you can use with this. I haven't got any, so I'm just doing all this via the command line for now. Okay, so that run that time. So I obviously did something wrong with the big query that I run. Maybe I was doing too much at once by creating the schema and then trying to insert at the same time, maybe. But anywho, I'm going to separate that out anyway once I script this. So now we've got a basic John Doe bank account. let me now go to the code base. And I've created this very, very simple package, which I'm going to then move into CopperMonkey. Great thing about this is I'm just making this package on its own. I'm just playing about. I'm just messing. I don't even have any tests yet. I'm just experimenting, playing about, seeing where I could put things. And I've got myself to a point where I've got a repository package. And in the repository package, I've got a couple of methods for inserting a client payment and getting client payment requests. Now, I don't like insert client payment, get client payment. It bugs me. So more than likely what I'll do is I'll change this repository and I'll call that, client payment respos, or just maybe even just client payment DB or something. Then I can do create, insert, update, and delete as methods to that repository and make it a bit more like a factory. Because there's going to be other tables, but I really dislike the naming there, and I did it, so I've only got myself to blame. If I jump to definition and go into this, in fact, let's go back. So I forgot. What we've got here is at the top. Let's change that because it was already John Doe that we put in. So let's do Connor. Why not? So we're going to create a new payment and then we're going to insert it, and hopefully we didn't get an error. And then what we're going to do is we're going to get the client payments, and then we're just going to loop through them and print out the account number. So nothing overly fantastic there, but hopefully this should be enough for me to run. And we hopefully should see down at the bottom that we got a payment for the new John Connor, 1, 2, 3, 4, 5, 6, and there was already one that we'd inserted in. So if I now do that again and scan that table, we'll see now that there are 2 records in there. Cool thing about this though is if I then run this again, which is this one, we hopefully are not going to get a new record for John Connor. Reason being is that John Connor's already in there with this account number. So we're not going to get that again. I wonder if I can just print it out like that. Maybe not. Okay, let's see if I can just print out the actual thing. Let's see if I can run that. So I want to just print it out and see if I can see everything. Yeah, there we go. So John Connor and John Doe. What I'm wondering is, can I actually change Connor? Let's just put in XXX at the end. Got that run quick. Awesome. So it did. So I'm able to mutate that exact same thing. So the insert client payment request is kind of a bit of a red herring, really, because it can do insert and update. So that's something to keep in mind when I'm building this this repository pattern out. So that's the basics of it. And, you know, that took, what, 10 minutes, 20 minutes to explain. Jesus, it took like 3 or 4 hours for me to actually get this working in the first place. It was a right pain in the ass because all the documentation's wanting you to do AWS and build everything on the cloud and use the tools in the cloud to build the database. I actually want local development. I want my developers to be building stuff locally. And I even want like as much end-to-end stuff as you can get locally, which means writing into a real database locally for end-to-end testing. It's just the way I live. If you can do that, then once it goes up to the cloud, you can be pretty sure that it's going to work. But then you've got your mock testing where you don't even access the database and so on and so on. So I kind of get it. I understand that some people don't even touch the database. You know, most of this code's not mine. You know, once you boil down to it, a lot of this isn't mine. So if I jump to definition on this, let's go to the top. So what I've got is I've got a configuration object which allows me to load the basic config. And the config from this will come from file, can come from environmental variables, but also you can seed it yourself. So at the moment, just for giggles, it's XXX as the actual login, and it's going to be localhost UK West, which will actually then connect it to the Docker instance running. So this stuff is bad. This stuff is obviously bad. So these things need to come from config files. So we need ability within this to be able to say whether we're getting from a DB local development. So we need to test if this is local or in AWS. That way we can load the local stuff and run connect to the local Docker, or we can connect to the other one. All of this is going to change once we start getting more cloudy. I know that sounds weird, but this is just to get stuff started. Eventually, we might not need any of this because the configuration will actually just be automatically inserted, but that's a long way down the line. Get client payments, get pending client payments, goes to this table and just simply scans the results, then unmarshals the data, and hopefully there's no errors. What are you doing? Oh, yeah. Then there's payments, and we use the account number, of course, as the primary key. So that's going in as key value per for this map, and then returns. Then insert, pretty much the same, but in opposite. Marshals, then puts into that table and get that. So I can see a couple of problems here. If we look at this, we've got a problem. In fact, table name is a string value. This needs to be controlled using config. Because we don't want a stringly typed table name. What happens if we change the table name? We're done for. And it's also in 2 places. So, you know, which is a bad idea. Table name is a string. It needs to be used in config. Thank you. So config, get, is there any other problems? Well, yeah, I mean, loads. If you consider using this as a package, if there's a marshalling error, what kind of error was it? You know, I want to experiment with this and say, right, what happens if I don't even have that property. What happens if that property spelt something different? What can happen to cause this to fail? And in that scenario, what do we actually get back from this? What does error end up looking like? So I can see myself building a raft of end-to-end unit tests just to see and check and then code for the different types of uncommercial errors. So, what does this look like? What type of errors get thrown, for want of a better word? How can I improve validation? So how can I improve validation? Then we'll come down here. Is account number the right key? Um, what right key? Because you could have multiple account numbers for different banks. So account number, I don't think is the right thing, and we'll get into this when I look at the state. This is just play. None of this is right. Just getting something that can read and write to the database. We'll start looking at the schema and what data we want in a second. So, right. Then insert. We've got the same kind of thing. The tables, commercial, same thing. What does this look like? What type of errors do we get thrown? These are the type of questions I want to ask myself. Therefore, these are the type of things that I want to think about. Then we've got a pending client payment, and say hello for some crazy reason. And we've even got the ability to change schema. So for instance, the database has got bank account, but our objects are account number, which is interesting actually. What did we have when we were creating it? So if I look at the README, bank account, okay, bank account, inserting bank account, right, okay, that's fine. So I like that. It can be misused. What's happening here is we've got a column called bank account, and this bank account is actually then being used as account number in code. If I can get to it, there we go. So here, account number is actually being used, which is interesting. So if we look at the top, you can see that the account number is being used there, and that's what you could use as your data objects. Where's insert? What file am I in? I'm in repository there. So if I go to main, we can see there I insert an account number. Now that's not good enough. I mean, for one, I'm going to probably use we're going to use our customer ID numbers. So ref ID, customer ID, I'm not quite 100% sure yet. So if I dive into Copper Monkey, and this is the main project, this is where my data repository is going to get imported into. Like I say, it's really cool this because I can play about here in this completely separate package. It's not even in Git. I'm just messing. And once I've got a feel, I'll actually then move it across into here, and then I'll clean it up and put unit tests on, and then do an initial commit and then I can actually wire this up to the commands for, you know, adding a payment request. I've still got loads of work to do here for validating things like the data types. But what I have got is we've got an add client payment request. At the moment, we've got an event ID, which is just going to be a GUID, which will follow the life for any kind of open telemetry and login. That will be like the trace ID that allows it to go all the way from start to finish. Request ID, span ID, trace ID, whatever you want to call it. Call it event ID, so might change that to request ID. Action was the unique type of action that we want to do. In this scenario, it's add client payment requests. Probably doesn't need to be in the table because that table will only be for client payment requests. Date requested, kind of. I'm sure there's a way of getting that out of Dynamo. I remember doing it a while ago, because all of this has got date inserted, date created, date updated as separate attributes to the input itself. So although here I've just got the table data, I'm sure there's a way of scanning and getting the additional data. So maybe date requested isn't needed. Amount, well, that's needed because that's the amount we want, and then the customer ID, so that becomes our primary key. Do we want to be allowed to make multiple requests for a customer? Is it a many table, or is it a single table? Does this table live forever? Is this something that we have as a client payment request, and then we update it as its status, you know, and we say whether it's done or not. Pending, cancelled, processed, you know, as some basic statuses as why did you close it? There's some basic statuses as meant to follow that buffer. So this is something to think about. I would prefer for this data to be short-lived in these tables, and for analytics and for reporting and for auditing purposes, this data should be streamed out of here and moved somewhere else. For now, I think that might be a little bit beyond what we're wanting to do at the moment, but I think that's something that I will do. I'll use Kafka or some streaming event. There's loads of them built into AWS as well that will just do it automatically. So when this data changes, it will be streamed into a change tracking system that will be able to audit when it changed. So for instance, when it changed to pending, when it changed to cancelled, if the amount was updated, so you can actually see change tracking that there was an original request where for £9.99, but then it got changed to £19.99. That was then cancelled, and then it was pending, and then it was processed. And you can see the history of this data request. And that's really good as change tracking. Beyond what I'm going to do for the meantime, I'm just more focused about bloody getting data in the database, right? So if I have a look at this, let's have a think about the data. I don't like event ID. Wonder if anything's using it. Doesn't appear to be. I want to make that request ID. Okay. There we go. So that's request ID. Action is the type of thing that we want to do. I'm not sure whether that's going to be needed at the moment. Date requested, it's useful, right? The amount, it's obviously going to be a float. Customer ID, GUID. I read an article recently about the problem with GUIDs and people using GUIDs for absolutely everything and it killing performance because there is a slight performance hit with using a GUID as a key rather than an integer. Think about it. Think about the size of the things and how much scanning it's got to do, how much paging is actually going on compared to what you'd have to do with an int. And it's been known for ages, but the performance problem here isn't going to be with the database, I don't think. We're going to be able to process probably 100,000 a second, which is great. Billions and billions a month. It will handle constantly. So customer ID, GUID, status, pending client, stringly typed statuses, dislike with a passion. But that looks okay. So that data type alone looks fine. So what I'm going to do is just take this and yank it. Let's write that. Oh, right, that. Okay, let's go here. Let's dive into pending client repository. So should be able to jump into here. I also don't like this. There should be a new. I dislike also types being just generated like that. Especially value types. Don't know why I've done that. Jump to definition. Here we go. Insert. Let's go down a couple. Let's add a comment for this. Okay. So just store this down here so that we've got it. There's a solid point there as well, and this is where I spoke about post-it cards. I'm actually waving a post-it card, but I realise you can't see me at the moment. One of the things I'll do is I'll write down on post-it cards what data I think I need and what will be needed by the next system. At the moment, I'm trying to guess, but I don't know yet what Stripe's going to need. If I don't even know if we're going to use Stripe yet. So I don't actually know what Stripe's going to need. But I know that it's going to need a payment request. I know with Stripe, you've got to create a client, you've got to create a request, you then got to process that request. So I know that there's a few things that are needed in order to create that client account. One of them being the first name, surname, and email address. So we actually don't have this in the client payment request data, which is the fun of this type of stuff. This is why this stuff's got to be made really, really flexible. But we've already got a command which has got a type, and now we're going to have a repository pattern which has got a type, and if they don't line up, then we're going to get marshalling problems, what everybody loves. And you're kind of creating a rod for your own back, but I don't want to use the same type. I don't want to tightly couple them types. I want, if anything, I need the ability to be able to convert a data type to let's do it old school, like we're in the 60s. I don't want an entity type to be converted to a data type, to be converted to a DTO type, to be converted to like a struct or a record. If we do, we can use converters and auto mappers that can do this. So that's another thing. But I would rather do that than try and marshal the same object all over the place and tightly couple the entire system. But there's an argument that by doing this, you're still tightly coupling them because you're going to still have some place that understands both types and converts one to the other. So have you really saved anything? It's a good question. Right, so now I've got a bit of data. I've got a database. I have some tables. I have a data type that I'm going to work on. I'm going to extend this. First name. Surname. Oh, why didn't you jump down? Surname. Email. So I'm not going to go through this. He says as I'm going through it. Request ID, action, amount, customer ID, first name, surname, email, and status. I think that is almost perfectamundo with no knowns at this point in time. Of course, it will not survive the war. It will not. It will go up in flames because that is life. But for now, this is a good model. It's a good amount of data and I can extend it and add to it over time. I now need, if I take this, let's yank that. Let's go to what we're looking for. Look at the README. I know there are tools, I know there are UIs, I know there are stuff that can do this. But for now, what I'm going to do is I'm going to see if I can use ChatGPT to just generate the table for me. Let's go into for all, let's go into a Gopher. Right. So what we're looking for, DynamoDB create table. Convert, using the following strut, create a DynamoDB table using, what's it called, create table, create table. So I think it should be able to work that out. No. This is interesting. I actually didn't know you could do this. I don't know why, because almost every crud on the planet can do this now. But of course, you can create the schema in code, obviously, like duh. So let's say most models work, which might actually be a good shout, you know, as an initialization. Instead of actually relying on scripts, do it in code, because then developers can write code, right? And if these things change, then you can update it, and you know you've got Git versioning that tells you when. So you've got like a database migration understanding as well. Your code and your schema become one, which is a good thing. I would love the actual table to be generated from the struct. That would be amazing. But for me, this didn't look complete as per, you know, typical chat GPT. Because where are my other columns? So there's a table called client payments. There's a request ID, date requested, request ID, date requested. And that looks like it's set it up as a dual key. And the partition key and then the sort key. Never asked for any of that. And then create it using basic to-do context. And that will create the table. So I might actually have a play about with that, you know. See if I can actually create the table in code. I won't do that live because that's just boring. It's just copying and pasting and faffing. Nobody wants to watch that. But that gives me another option. So what I'm going to do is off video, and I'll commit this, of course, to Git, and I'll just document it a little bit within the comments below. But what I'll do is I'll just create these database and I'll create this table. Is anyone in chat? No, all alone. And what I'll then do is in main, what I can do is have a create schema or DB migration, and then I can actually put migration code into the repository. So, you know, when a new table is created or something, I can actually create a new migration file. That might be pretty cool. It makes it easy to understand how things have changed. But for now, what I want to do is create the database that has got that schema and insert and play about and get this repository into a state that's usable without too much messing, and then copy and paste that into this as a package and wire it up. So that's going to be something I'm going to do off camera. It's literally is boilerplate code, and it's going to be incredibly boring. Might record it, play it back, and then, you know, show it so I can show you how I did it, but then I can fast forward all the boring bits and me typing at 2 miles an hour that no one wants to watch. Anyway, I hope you liked it. As always, my name is The Gizzard, and have